Hi guys, the purpose of this video is to show you how to draw a linear model on a scatter plot that fits the overall pattern of the data, and also how to then find the slope of that line, or actually really how to find the equation of that line. So here I have an example of a scatter plot. This is relating the amount of sodium per serving of peanut butter and also the price per serving of peanut butter. So you can kind of see by looking at this scatter plot that the data has a negative slope to it. Any line that goes through this scatter plot is going to have to slant down and to the right because we have like a negative relationship going on here. So I know that I could just draw a line somewhere in this data that kind of fits most of the points, or that kind of goes through the middle of most of the points. And that would be fine if all I wanted to do was maybe see a correlation, estimate what correlation these variables have. But I know, looking ahead, that I'm going to have to find the slope of the line, and I would imagine that eventually I'm going to have to find the equation for the line. So I don't want any line that's just kind of going through willy-nilly points. I want to be careful about the line that I draw, because in order to find a slope, you know that you're going to need 2 points, an x value and a y value, and another x value and a y value, so that you can use the 2-point formula to calculate that slope, and then going further to calculate the whole entire equation. So when I draw my line, I want to make sure that it's going through 2 points that I can actually use when I get down to this step. So I have 2 options here. I can pick 2 actual data points, like 2 of these dots, and make sure that the line that I draw goes through those 2 dots. So maybe I want it to go through this point here and this point here. So I would line up my ruler between those points, and I would draw the line that goes right through those points and use those points to calculate the slope and use that slope to find the equation of the line. However, in this situation, I don't really know what those points are. Like, I can estimate that this point might be, let's see, this would be 7.5, so maybe that's like 8, and this would be 275 to maybe 260, 260 maybe, but I don't know that for sure. And so I'm going to make it even easier on myself, and I'm going to make sure that the line that I draw goes right through the intersection of 2 grid marks. I'm going to find 2 grid marks, 2 grid intersections here, one kind of up here at the beginning of my data and one down here at the end of my data, so that I know for sure what those points are when I go to calculate the slope of the line. So it looks like if I put my ruler right about here, that looks like I'm pretty satisfied with that line going through most of the data. And there's a point right here, not a point of like data, but a point where the lines intersect each other, the grid lines given intersect each other. And there's a point down here where the grid lines intersect each other. So I'm going to use that, whoops, I'm going to use that one too. Okay. So there's my line. I used this point, and I used this point. And so this one is 5,275. And this one was 27.5, 150. So I can use these 2 points to go on to the next step, which is to find the slope, and I'm just going to do that using the 2-point formula that we have talked about in the past. Once I get the slope, I can then do some algebra and solve for b, or solve for my y-intercept, and then I'll have the whole equation in y equals mx plus b form.